There we go. Cool. All right. So I hope everybody's having a good day so far. It's a beautiful sunshiny day, and you've got to enjoy this nice weather for the next several days because it's supposed to take a turn, at least temporarily. So anyhow, for me, that means that I have a lot of garden work to do, and I've got to do all my harvesting, and that's pretty darn exciting. But let me see. So in terms of class, I left you all with a cliffhanger yesterday. And so I want to pick up where we left off. We are like 3 minutes away from finishing lesson 8. And then we're going to jump into lesson 9. Lesson 9 is kind of like a non-section, really. I have to show you how to use your calculators. So I'm going to do that. But once we're done with lesson 8, we're done with our probability unit, and then we're going to jump into our statistics unit. Once we're done with, it's okay. No, it's chill. I assure you. Okay. I love your facial expression. So what I want to say about the statistics unit is we're not going to go very deep at all. If you need to take a statistics course for your major, you will go a lot deeper in your statistics course. But of course, we're going to cover enough so that you're prepared for it. And then once we're done with our statistics section, we're going to have our next test. And then the whole nature of this class is going to change, and we're going to be doing linear math. And that's what your third test is on, which happens during finals week. So in terms of immediate things, lesson 7 online homework is due tonight by midnight. I got it straight this time. I messed up yesterday. So please make sure you finish it. I want to add that I have gone through pretty much every single online homework question in lesson 7 in class. So I strongly recommend, if you're having difficulties with that, that you need to access the videos from the class. Okay. So certainly do that. That's the beauty of having this box folder and for me recording class and uploading the class notes. So number 1, please make sure you get the lesson 7 online homework due tonight by midnight. Number 2, this class activity number 5 is due Friday in class. You can either email it to me by the end of class, or you can actually physically bring it to me on Friday. Whatever you want to do is totally cool with me. Okay? Nice. All right. So, picking up where we left off yesterday, we played a little bit of hang person. Because the question that I had posed was, and again, if you weren't in class yesterday, please be sure you get the class notes from the box folder. But essentially, we talked about medication being effective for 92% of the people taking it, and it was given to 300 people. And what we wanted to know is how many would we expect to find the medication to be effective? Now, where we left off class yesterday was like, well, when we're dealing with expected value, we know that what we need to do is make a probability distribution table. And what we came across yesterday when we were making that probability distribution table was that there is no way you'd want to do that, because essentially what we would then have to do is find the probability that no one found it effective, that one person found it effective, that 2 people found it effective, all the way up through 300, right? Because what we've seen so far with our probability distribution tables and expected value is the way you find your expected value is you take each X value times its corresponding probability and add it up, okay? Making 301 columns in a probability distribution table is simply a waste of anybody's time, okay? So the question is, how could we figure this out, okay? Again, because this is a binomial distribution, which we saw at the end of class yesterday, okay? Again, if you don't remember why it's binomial because an experiment is repeated several times. In fact, this medication is given to 300 people. Number two, there's only two possible outcomes. Either it's effective or it's not effective. And then finally, number three, each trial is independent. So whether or not the medication is effective for one person is completely independent as to whether it's effective for another person, i.e. the probability doesn't change, okay? So let's intuit this instead, okay? Instead of doing all these math formulas, we're gonna come up with another equation, but I want you to intuit it. What do we expect to happen? Well, this medication is effective for 92% of the people who take it. Do you agree with me there? At least that's what the statement of the silly examples tells us. So we would expect it to be effective for 92% of how many people? Say it out loud. 300 people. You got to trust yourself. Okay. Wouldn't we expect it to be effective for 92% of 300 people? What is of in math? What operation does that tell us to do? Good. Of in math means multiply. So we would say 92%, we've got to change it to decimal form, times 300, and we just get 276. So the beautiful thing is as follows. When you have a binomial distribution and you are asked to find the expected value, didn't we just take our n value and multiply it by our p-value? Right? N is the total number of people or experiments, and p is the probability. So this should make you smile. The point being that so far what we've done when we have found our expected value is we've had to make a probability distribution table, okay? We saw that with examples with combinations. We saw that with examples of raffles and life insurance policies and all sorts of other things. But when you are asked to find the expected value and you identify the distribution as being binomial, this is all you have to do. Isn't that cool? All right. So what I want to do right now is share my screen. All right, so here we are on the MyOpenMath. Mine looks a little different than yours, but I'm going to go to this unit 2. So we have just finished lesson 8. And what I want to do is a couple of things with you. Number one, I want to assign the homework to be due a week from today. And I don't even know what the date is today, the 19th. Okay, so your online homework is due a week from today for this section. But what I want to also do is talk about it, okay? Now, I want to say this loud and clear. Today, I am talking about the lesson 8 online homework. Take notes, okay? Because I'm going to give you a couple of hints. And I don't want to have to keep giving the same hints again and again. So I'm going to direct people to this class recording, okay? So in terms of this lesson 8 online homework, number 1's a multiple choice question. We know that when we talk about expected value, we're talking about long-term averages, okay? For number 2, your probability distribution table is going to look different than mine. But here you're given this sample probability distribution table, and all you're asked to do is find the expected value. How do you find the expected value? You take each X value times its corresponding probability and add it up. All you're doing in question number 2 is simply using the formula. Don't make it harder than it is. Thumbs up, okay? All right, question number 3, they're giving you a little game and you need to make a probability distribution table and find the expected value, okay? It's a cute little game. Don't look deeper than it is. I claim if you're comfortable with those raffle questions we did yesterday, this goes along very, very similar lines. Question 4 is the most involved. You want to use combinations for question 4. It's like your last dose of combinations, okay? And you're going to want to write that down as a hint. It'll help you. I will not test you anymore on a probability distribution table with combinations, but it's totally fair game for an online homework question. Okay, this is the one online homework question that you need to use combinations. You dig? Cool. All right, so questions 5 and 6 both address life insurance policies. We played with an example yesterday in class on life insurance policies. Your numbers are going to look different than mine. But again, as I always go back, it's kind of sort of all about the vibe. And what I want to point out is that you need to read carefully. Like for me in number 5, I want to find the expected value for the person buying the insurance. And in number 6, I'm asked to find the expected value for the insurance company. Remember how we looked at that yesterday? Because it depends upon the perspective that you're looking at. Okay, so number 7 and 8 are the raffle questions. They're slightly different from each other, but this gives you 2 places that you can practice doing the raffle questions. Okay, you can refer to your notes yesterday for that. So question number 9, okay? They want you to find the expected value, okay? Notice we are given that a certain percentage of Connecticut residents have type B blood. 24 residents are experimented on, if you will, and we want to find the expected number. Do we need to make a probability distribution table here? Good, no, we don't. You know why? What type of distribution is number 9? Binomial. That's where we use what we just did. You just take your N, which in my case is 24, times your P. So I would put 9.4% in decimal form, and I would multiply. Don't make this more difficult. And question number 10 is another opportunity for you to practice binomial. Question number 10 is another binomial. Again, the biggest hint I can give you for binomial when you have a binomial question is when a percentage is given to you. Okay, because that's the probability, it does not change. So in terms of relating to lesson 8, part F is the only one that relates to this, right? You're finding the expected value, you take your N times your P. Parts A through E just give you more of an quote unquote opportunity to practice doing binomial PDF or binomial CDF in your calculator as if you didn't have enough in lesson 7. Does this help? Cool, cool. All right. Whoa, I want to share my screen again. I didn't mean to do that. Hold on one second. So now what I'm going to show you all is that, and I'll show it to you from your perspective, we have now finished Unit 2. Woohoo! Oh yeah. So what we are going to bop to now is Unit 3. This is on statistics. Okay, this is fun stuff. I promise you, I am going to walk you through it step by step. Okay, we're not going to get really deep here. I will say that lessons 10 and 11 are very inextricably linked. What I want to say about lesson 9 is as follows. These are calculator questions for the most part. I'm not really asking you to do any of this stuff by hand. We have the technology. For goodness sakes, let's use it. I will show you how to use the calculator in class, okay? But it is up to you to access these instructions as we go, okay? Lesson 9 is very chill. I'll talk about the homework and all of that stuff later. What I want to say is as follows. There are some calculator instructions with video lessons here that you can refer to, but these use the TI 83 and 84 calculators, which I will show you in class because I know people have them, but I will also show you how to do this on our TI 36X Pro. Cool? All right, so y'all psyched? Well, it's a good thing I am. All right, what we're going to do is talk about lesson 9. This will not take us long. And I claim you've learned this stuff at some point in your life. Okay? Whether you remember it, of course, is a whole different ballgame. And I totally get that. That's why I'm in here going to go through it with you, okay? So what I'm gonna do is I'm gonna talk about the ideas in lesson 9, give you the definitions, and then I'm gonna show you how to push the corresponding buttons on your calculator. And at the end of lesson 9, I will do exactly what I did with lesson 8, kind of walk you through your online homework so you know how to go about doing it. Cool? Okay, so what am I talking about measures of center? Well, when we talk about measures of center, we're talking about mean, median, and mode. Okay, you've heard these terms at some point in your life. I know you've heard the term mean before because we've used it in the last section. But what I want to do is I want to talk to you about each of them and about the differences, okay? Again, I never ask you to memorize any definitions, but it's important to know what these are used for and when they're used. So when people talk about like newspapers lying with using statistics, using these measures of center is a really nifty way of lying with statistics. And I'll give you a classic example of it, okay? So the mean is the one that we've talked about. That is literally the average as we know it. Now, I am not going to ask you to do anything like these things by hand. I will show you how to do them on your calculator, okay? So average as we know it, what do? We add up all of the data points, and then we divide by the total number of data points. Now, I want to bring out some things here. So suppose we have a series of test scores, okay? Suppose we have like 6 mini tests in a class. And we get a 95 on the first one, an 85, then a 91, then a 98, then a 32. We didn't feel very good that day. And then a 93. Okay? So suppose we wanted to find our average test score, or what our teacher would give us as a grade in the class. Okay, what would we do here? You got it. We'd add up all 6 of these numbers and then divide by 6. Okay, so if I add up all these 6 numbers, I'm going to get 494. I did the computation already. And I divide by 6, and I would get an 82.3. So if I was the type of instructor who just looked at numbers and didn't consider anything in detail, what grade would this person get? They'd get a B. Now, I'm not that sort of person, precisely because I recognize the human aspects of life. And I would look at this person's scores. Okay, when I say it's all about the vibe, I'm really serious. I hold myself to that too. I look at these scores and I'm like, this is an A student who had a really bad day. Don't you agree with me? Okay, I look at this number and I call that number an outlier. And you're going to get really into talking about outliers if you ever take a statistics class. But it literally is what it sounds like. Now, there's good outliers to have, right? Like if you get C's on all your tests and then you get 100% on one of them, that's like a woohoo. I love that outlier. But this is an outlier in a really yucky direction, okay? So if I looked at this and I said, wow, that's really like an anomaly here. I wonder how this person did if I didn't count that value. Well, what I could do is add up all the other 5 scores and then divide by 5, because now I'm looking at 5 scores. And they would have that A in the class, like I think that they would deserve. Okay? So this is why when I tell you I'm not just a straight up numbers person when I compute grades, this is precisely the reason why. Okay? I look at all of you holistically because I think that's really important. We all need a mulligan in life. Okay? So what caused the difference? This outlier. So what I want to say is, if you want to talk about outliers, loosely put, they're data values that differ. pretty drastically from the others. And I really sincerely look at that. Y'all cool with the mean? Okay. So the next, and we'll get to the calculator pushing buttons probably on Friday, but we'll finish up lesson 9 on Friday for sure. Okay, so there's our mean. Now, another common way to measure our center is called the median. Okay, again, our calculator will give us this value, but it is by definition the middle value. Okay, what do we mean by that? Well, what we mean by that is what you would need to do is order the data from smallest to largest and take the middle value. So clearly, if you have just a bunch of random data, taking the middle value is not at all meaningful. You have to order it from smallest to largest. And again, your calculator will take care of that. Excel spreadsheets take care of that. So it's a pain if you have to do it by hand, but we don't really have to. So you might ask, when would we use the median? And I claim that the median is used very frequently, okay? So suppose you're moving to a new town and you want to know what is the average home price or what is the average rent for a 2-bedroom apartment. They don't take the mean when they do that. They take the median, the middle value. So when you're looking at average home prices, average rental, average income, you're looking at the median, the middle. When you talk about like, oh, I want to move to this town, I want to move there and make sure that there's people in my age group. What is the average age of the people who live in this town? That is also your median. So when you're talking about your median, what you're saying is if this is your median, 50% of the data values are more than that value, and 50% of the data values are less. It is literally the middle. It's the balance point. Yes? We will talk about that in a second. I will talk about how to find it in just a moment. Okay? So I just wanted to let you know that this is used. Okay? So if you want to go talk to Google and find out like average home price, I happened to look, I don't know why I looked it up, but I was looking at something in Bozeman, and the median home price right now in Bozeman is over $800,000. That means that 50% of the homes in Bozeman right now are currently selling for more than $800,000. And 50% are selling for less. Okay, it's crazy stuff. But this is a real big way that you can quote unquote lie with statistics, because when you're talking about your average, they don't have to specify that they were using the median or the mean. Okay. So let me talk about how you do this if you wanted to do it by hand, and then I'm going to give you a pretty classic example of how a boarding school out in Washington state lied with statistics, okay? Isn't this kind of fun? Like, this is really practical, like read a newspaper, understand when they say the mean versus the median, you're looking at two very different things, okay? So if you have an odd number, and this isn't anything you're going to really have to worry about yourself, unless you're doing the median by hand. But if you have an odd number of data values, you literally take the middle value. Okay, again, you have to order them from smallest to largest, and then you take the middle one. On the other hand, if you have an even number of data values, there is no one middle value. And I'll show you by an example in just a moment. So what we do is we take the mean, or that average, of the two middle values. And again, technology will deal with that for you. So suppose I have the following values: 32, 77, 78, 83, 89, 94, 97. Suppose these were a bunch of test scores in the class. And I wanted to know, what is my median? The way I think of the median again is it's kind of like the balance point on the scale, right? Half or more, half or less. Well, notice I was already nice here. I already ordered these from smallest to largest. Might as well save us a hassle. And we have 1, 2, 3, 4, 5, 6, 7. So I claim, since we have an odd number of data values, there is a middle. Watch this. Start on the outside and count in. Doink. 83 is our median. It's just extremely literal. Now, on the other hand, what if I just nix this 32 and I say, suppose these are the scores? Now we only have 6 scores. And watch this. You're going to see that we don't have a middle value. You start on the outside and you jump in and you have these 2 middle values. So how do we find the median in this case? We take the average of the 2 middle values. So literally I would say, well, 83 plus 89 divided by 2. And so in this second one, my median would be 86. You cool? Is this kind of sweet relief compared to what we have been doing? Good. I hope so. It's nice to have that sometimes. All right. So, what is that famous example that I've been talking about? And famous, I'm putting in quotes, not like, you know, math examples acquire a lot of fame in them. But here's an amusing example. So there's a boarding school, boarding high school out in the state of Washington, okay? And the way they advertise themselves is they say that the average income of its graduates is over $1 million. So parents might be like, whoa, I certainly want to send my kid there because my kid then maybe will have a lot of money and be able to support me in my old age, right? I mean, when you hear the average income is over $1 million, that's somewhat compelling. Won't do you a heck of a lot of good in Bozeman buying a house, but anyway, that's a whole nother matter. And they're not lying, okay? They were talking about the average, like add up all of the incomes and then divide by the total number of incomes they added up, okay? But that's not accurate, okay? Or it's not entirely truthful. Why? Because they were using the mean and not the median. What they leave out is that Bill Gates, Steve Jobs, and a couple other huge Silicon Valley people who are like billionaires went there. So everybody else could be, you know, nearly homeless or have next to nothing. And these billionaires, once you know, include them in your average, they're going to skew your data really far over, okay? So a more accurate representation, again, would be the median, okay? Because then 50% of the people make more, 50% of the people make less. But unless people know what statistic you're looking at, the mean versus the median, it's a pretty compelling argument, okay? So these are the ways that companies can lie about, you know, their worth by using a statistic that's true and that's accurate, but not necessarily appropriate for that circumstance. Being a skeptic is a beautiful thing. Okay. So I'm going to give you one more today. I'm going to talk about this just momentarily. And then what we're going to do is say see ya until Friday. Okay. So the mode is the third measure of center. Okay. And this is maybe one that you haven't seen, but the mode is a really important one when you start looking at frequency data. But the mode is the most frequently occurring data value. It's nothing that I ever use, you know, in my work here. And I'm going to add that there can be one mode if one data point occurs more frequently than the others. There can be no mode, and that's if all data points occur the same number of times, or there can be several modes. Okay, we're going to notice modes when we start doing normal distributions next week, or probably at the end of next week. Okay, in and of itself, like if I'm looking at test scores, I don't really care what the most frequently occurring test score is. Okay, no offense. So when would you want to use this? Well, suppose that you manage a shoe store and there's a really popular shoe style, okay? And you need to put in an order for more shoes, okay? Well, you're gonna look at the sizes that you've sold so that you can put in a new order. Are you gonna take the average of all the sizes that you sold in order to know how to put in your order? No. Are you gonna take the median shoe size and make your order from there? No. Okay, you're going to take the mode. You're going to ask yourself what shoe size is sold most frequently, and I'm going to want to buy those. Does that make sense? Okay, so I'm just going to write down two very quick examples. So suppose we have this, and I'm just writing down a bunch of numbers. And then I'm going to write down one more bunch of numbers. All right. So in my top row of numbers, what's my mode? Or what are my modes? You got it. We have two modes, right? 92 occurs once or twice, sorry, and 91 occurs twice. Everyone else occurs once. So we have two modes. The mode is not 2, it's the actual data values. How about in this bottom row? Do I have any modes here? Does anyone occur more frequently than anyone else? No, so there's none. So what I'm going to say to you all is on Friday in class, I'm going to tell you how to push the buttons on your calculator so that you're able to do this assignment, but we've gotten through all of the substance. Now, will you all grant me one thing? Wasn't this section pretty chill comparatively? Yeah. All right. I hope you all have an awesome day today and an awesome day tomorrow, and I will see you Friday morning.